Hello everyone. Today I'm gonna give it a try to Unison. Uh, I'm looking at the website right now. Unison is in public alpha, and there's a lot of stuff that's still missing. Like there's no proper base library. A lot of things cannot be done, and I feel like probably there's no way to actually run a program except for running code in the REPL. Uh, anyways, I'm not actually trying it right now. I already played with it a bit. Has some very cool ideas. Some other things that are really a bit hard to wrap one's head around because it's a pretty different paradigm to what I guess most of us are used to. Anyways, uh, it is based on a simple idea with big implications. Code is content address that is immutable. So this lets us reimagine many aspects of how a programming language works. We simplify code-based management. Unison has no builds, no dependency conflicts, and renaming things is trivial. The same core idea forms the basis for runtime that robustly supports dynamic code deployment, allowing a single Unison program to describe entire Elastic distributed systems. So I have to say that I have zero experience with distributed systems, so I just have to trust them on these claims, which I'm thinking about it a little, make a lot of sense. Uh, but I have no background to really comment on them. So the the big idea is that uh, code is immutable, like functional programming has brought us the idea that content, that data is immutable, mostly. Here they bring them to the next level by saying that even code has to be immutable. So let's take a look at the docs. I think they describe this much better than what I can do. It's probably here in the tour of Unison. Yeah, so in Unison, definitions are identified by content. Each definition is some syntax tree, and by hashing this tree in a way that incorporates the hashes of all the definition dependencies, we obtain a Unison hash which uniquely identifies that definition. This is the basis for some serious improvements to the programmer experience, eliminates builds and most dependency conflicts, allows for an easy dynamic deployment of code, type out of durable storage, and lots more. I imagine there will be also some kind of very weird and different ID for this language. We'll see. So if definitions are defined by their content, there is no such thing as changing a definition, only introducing new definitions. And also, yeah, definitions can have multiple names which map to the same thing. Unison definitions are like stars in the sky. We can discover the stars in the sky and pick different names for these stars. But the stars exist independently of what we choose to call them. Yeah, it's weird. Uh, a big question that arose. Even if definitions themselves aren't changing, we do sometimes want to change which definitions we are interested in and assign nice names to. So how does that work? How do you refactor upgrade code? Is the code base still just a mutable bag of text files or do we need something else? We do need something else, and it's the Unison code base manager, which is the thing we're going to be playing with today. Yeah, so basically it's just a database which holds all your code base, the code you're working on currently, all the libraries you're using, and so forth. Uh, it integrates Git, integrates some commands that are very similar to navigating in the terminal through folders and files. Some commands are pretty similar to what you could find with Hackage, Stackage, or whatever if you're used to working with Haskell. Sorry, just a sec. Uh, yeah, and names are stored separately from definitions, so renaming is fast and 100% accurate. Well, except for the fact that obviously they're in half right now, so things sometimes broke pretty spectacularly. But yeah, there is an undo command, but don't really do. And then we'll move to Scratch files. Try writing some code now, and we'll see how this works. So right now there are not many libraries online yet. Probably less than 10. And the not ideal thing is that right now code is pushed to this library, to these repositories as uh, just binaries, basically. I don't know if binary is the right word, but it's just the hash syntax tree. So there is actually no way to go to GitHub and explore a repo and see, okay, this is how they wrote their code. The only way to do so right now is to pull the repo and explore the library, which in this alpha period of the language, it's not optimal because sometimes library it's not up to the last version of the compiler and things broke and then it's not possible at all to explore the code. I know that someone, sorry, is writing a repo explorer in Elm, which I hope will be ready soon, and it's very interesting. Also, another weird thing which I'm still having trouble wrapping my head around is that it seems like they encourage you to have a single repo holding all your libraries, uh, which is weird. I don't know. There are a lot of new paradigms which I guess will take some time to get used to. So, anyways, already talked way too much. I already installed Unison by pulling the latest version because the release is a couple months old, I think. The latest release. Let's see how it goes. So we can run UCM here, and it tells us there is no code base, and we have to run UCM init. We can also specify it here, so if we want to work on a clean code base, we are allowed to do so. But if we do so, it's initialized into the .unison folder in our own folder. So let's see what's in there. V1. There's a bunch of stuff, which is probably gonna be mostly empty. But as you can see, it's a lot of hash stuff. So this is what you can see if you go check the repository of any of the libraries that are running right now. So it's not very helpful at all. Well, anyways, so we initialize our code base. Now we can run UCM. And we get this nice interface. It tells us to pull the base library. Yeah, so let's do that. So as you can see, it includes a lot of commands taken from Git. Gonna be very familiar. Web base. We're pulling the trunk into the base namespace. So the dot means that it's the root, and base is just a namespace. So we're pulling this into base. So it's gonna download some stuff. There was some issue with pulling and merging a couple of weeks ago, and I know that they're reworking their code base and management completely to improve performance. So things could be a little weird, but maybe it will improve pretty soon. So yeah, here's what changed in base after the merge. Added a few definitions. Okay, a lot of definitions. You can use to do to see if it is generated any work to do in this namespace and test to run the tests. Oh, that's cool. Or you can use undo or reflog to undo the results of this merge. Is there actually any to do here? Yeah, I know. What if we run test? Yeah. So it ran a lot of tests, and you, you might say, wow, that was very fast. Well, that's actually because I don't think the tests were really run because there is no need to. Because if code is immutable and I didn't make any change, then tests can be kind of be mutable too. Unison is smart and only runs the tests that are actually needed. So I think this is awesome and something that can improve coding cycle speed a lot. So, anyways, we are here. If we run help, we get a lot of comments. We'll try following the quick tour, the guide, and see how it goes. But anyways, we can list the namespace, and we only have base. We can go into base. Let's see what's in here. There's a lot of stuff. Something that's very confusing and always bites me is that cd dot dot doesn't work. What it actually does is it takes you to the dot namespace inside of root. And I think this used to break everything if we release this ago. Now it doesn't break everything, but it just takes you to the wrong namespace. So it's a little annoying because if I navigate into base, maybe dot list, no, list dot, yeah, display everything. Dot filter, and then I say, okay, now I'll go back one level. I can really do that. So I have to go back to type base dot list. It's a little annoying. Let's go into base. Anyways, so I can list things. I can find stuff. Let's find map. And I get everything that contains the word map in it. Or I can do type driven searches. So for example, let's say, let's find everything that goes from a list to a list. And then I got a few matches and then say, okay, show me 4. So when you do find or list and you get these number results, you can use the number to quickly access to one of the results. So I can do view 4 and I get the implementation, which is probably not what was written when the reverse was implemented, but this is only how Unison shows us the implementation. Because so the implementation is not actually what's stored in Unison, it's only the hash. So another cool thing is that docs are saved in the code base and are linked to the functions. So for example, we're not gonna have docs for everything because obviously they're still building implementing things. But from here I can see that if I write, for example, docs for list non-empty dot fold map, then we get the documentation. So transform every value of an empty list with a unary function and apply the static boundary operator to all the results. Example, list non-empty, fold map examples x1, and it gives us an example, which is some code. And I think this code is actually type checked and run. So we're guaranteed that the example is correct and real. If this is not true, sorry. But I think it's true. Uh, So what else? We got a few commands that we can run to rename stuff. I guess we can try them, and even if I break my code base, we don't really care that much. So for example, let's find what we are for fold. So we have fold L, fold F, fold R, sorry, instead of list. So what we can do is, for example, move term list fold because we don't like this name, and we can rename it fold left. It says done. Cool. So what do we now search for fold? If we search for fold, nothing happened. That's weird. Okay, we are a fold left now. But we still have the fold L. So let's see. Move term or rename term. Move term for bar renames foo to bar. That's what we did. Uh, oh, sorry. I was looking at the wrong thing because I was looking at set. That's actually what happened. So now fold L is called fold left. But the cool thing is that if you had some code that used fold left, uh, actually nothing would have broken because our code would have referred to the hash, not to the actual name. And now all our code and the code of our coworkers, of everyone that's using our library, still works. The only thing that's changed is that the function changed name from fold out to fold left. And then we can undo. And here's the change ended. And so it changed back fold left to fold all. So yeah, we have our fold all back again. So now we can move to another very confusing aspect, which is how you write code in Unison. And also it's what makes me think that the IDE will be something completely different to what we are used to right now. So when you run UCM in a folder, Unison looks for scratch files, which are files which are ending with the .u extension. And what it does is parses the file and tries to run it. So right now this is my scratch file, scratch u, and it's empty. By the way, I'm using Emacs and a very simple syntax highlighter I wrote for Unison, which is mostly broken, but it works for now. So let's try to do something. So just following the tour for now. So the syntax is pretty similar to Haskell, if we're used to it. And this is how we define a function. So we have the function name, and then we can specify a type, which is disability, and then we define the function body. And now look, we save this file, and here it's very cool. Let's say I found and type check these definitions. If you do an add or an update, here's how your code base will change. These new definitions are okay to add square from nat to nat. Okay, so the point is that now you've written this function, we are satisfied with it. We can add it. So we type add here. And it says I've added this definition. So now if you do find square, we have our square function. But the point is that we don't need this anymore, so we can delete it. And here we still have our square. That's pretty weird. Another thing we could do instead of deleting it, which is something that sometimes is good, sometimes leads to very confusing files, but if we put these triple dashes, which is called fold, everything below this is ignored. So we can save, and actually Unison says that it didn't find anything. So that's pretty nice. Another cool thing we can do, it's watch expressions. So if we do this angular, how do you call this, caret? I don't know. Just start with this, and then you say square 4, and then we save. This gets evaluated. And now it says, yeah, square of 4 equals 16. That's pretty cool. So what if we create square square. Oh, by the way, there is no $sign right now. And there's also very limited support for infix operators, so that's a little annoying, and I hope they will fix this soon. So now we have this square square definition. It's okay to add. Before adding it, maybe we can want to try it. Square 2, which is a horrible name, and it gets, yeah, power of 4. Ah, that's good. Uh, so let's add it. And now we have two square functions. So what happens if we do a move term square to, let's give it a different name, square. Say it's done. So the cool thing now, as I showed you, anticipated before, is that we can still call our square square, and it still works, even though our square function changed name. It's not square anymore. This is very interesting. So another thing we can do, we can create our own namespace to work on things, so we don't pollute the base namespace and makes things easier to work with. So for example, we can go into a new namespace, and then we can do move term square. Sorry, it's base is square into base Dario square, and then do a move term base square square into base Dario square. Sorry, square. It's a very poor choice for names. Okay, done. And now we have square, square, square inside of my namespace. Pretty cool. So, well, the syntax is pretty straightforward for basic things. A cool thing is that we can also test code from here. So, for example, we can do this test square test x1. Say that check that square of 2 equals 4. There is a k where it shouldn't be. These new definitions are okay to add. So it runs the test and also tells me that it knows that this is a test because it starts with a test, and these are okay to add. So we went to add them, and now if we search here, we can see that we have this square function, but under square we have another namespace we can navigate into, and we have our tests. So everything is packed in our code base. Tests, our definitions. We can also write documentation. So let me just quickly check. Okay. If I remember correctly, documentation is done something like this. If I'm wrong, I'm gonna just check the website. So square doc equals, this is the syntax for multi-line documentation. Then we say this function squares the input. But let me just check very quickly because there are a couple of cool things we can do inside documentation. so we can link other functions. So let's do this. Now let's do the square. I really hate choosing this name. Square, square doc, which is a doc. This function squares the square of the input, and then we can say it basically runs square twice. So let's see what happens now. I found and I checked these definitions. If you do another update, that's how your code base will change. So we can add them, and then we can view square doc. We can view square doc. Yeah, that this didn't do what I thought it was supposed to do. Okay, we have a few things we can do here. We can do this signature square. Let's move this below the fold. Update. Let's see, view square doc. Okay, why is it not working? I think it's not working because I haven't linked the square documentation to the term, which, if I remember correctly, is done by using the link. Let's try. Link square doc square. Okay, updates. So now if I do doc square, docs square, sorry. Yeah, I get my doc. And now hopefully if I look at my square doc, yeah, it doesn't work. I think I'm messing something up. So insert the type signature of a term in the code base. You can include type signature of any function or value in the code base with at square bracket signature followed by the name of the function or value. It's not working. Maybe something that they're working on and it's not here yet. Now let's see if something else works. So for example, there's the evaluate square 2 update view square doc. Oh, you know what? I think I have to link this because I'm viewing it. That's not the correct way to do this. So I have to link it to square. And now if I do docs square, yeah, it works. Oh, my bad. So it's pretty cool. It basically runs square, not twice. And this evaluate, it's not doing what I thought it would have done. So maybe I have to do this. No. So here in the example, they use use a function. They didn't use some code that has to be evaluated here. So they do something like let's go above the fold. They do something like square dot examples dot x1, and this is like square 4, which I get an error because I need this. This now is okay to add. We can add it. Now we can delete this stuff, and then we can use square examples x1. So it's okay to update. Now I don't think documentation linking updates automatically yet. So I think we have to do unlink. So unlink square doc square, and then we can link it back. Yeah, it works. That's pretty nice. So maybe we can do something like sort square examples x1, and then I say returns something like this. And then we can update. And sadly, we have to do this little trip again. I relink it, and then we can see the docs. Yeah, should have gone another line down, probably. Because everything is on the same line, but yeah, it's not that important right now. Let's see if there's something else on the tour that I didn't cover yet. Oh, there's property testing, which is pretty nice. So now we can basically delete all Scratch file because we don't need this code. Everything is already in our code base. So we can use test. So we are basically loading this namespace or this library. I don't know how you want to call it. So we already had one test. I don't know if we added it to the code base. Test square, one test passing, which is not actually running as I told you because, yeah, our function didn't change. So we can add another test. So let's do test, square tests prop1. And this one it says go. And it's also going to show some additional syntax here, which is pretty fundamental to Unison right now. Okay, let's see first if it works. Yeah, it ran 100 tests and say that it passed. And as you can see, it wasn't instant. Maybe we can do like a bigger number to show this. Let's run 10,000 tests. Yeah, it's taking a while. Was it too big of a number? Yeah. Yeah. Okay, let's try with 1,000. Yeah, it passed. It took a while. What now if we change a Scratch file? Sorry. See? The test was instant. Also says it here. If you don't believe my words, that was cached because the test didn't change, our code didn't change, nothing changed. And Unison didn't actually need to run these tests again. So there are a couple. Sorry, just a second. There are a couple of things that you can see here. This this exclamation mark actually is. Let me show. Let's search for NAT, our code base. A lot of results. So maybe we can search for test.NAT. No results because we are inside of our Dario code base. So it's this. No results. What am I doing wrong? Okay. So let's move to the test namespace and then we can search for NAT. And we still get a lot of results. But we have here the number one. So we're looking for. So let's view one. So yeah, I don't think there's documentations for it. Yeah, no results yet. We can see that this function does this weird thing, which you could say it's an effectful computation that returns an at. And there's this apex here. So this apex is actually sugar for something like this. So if we write nat, it's as if we were writing from unit to nat. It's actually a trunk. And if we write nat, it's actually, so let's ignore this curly braces thing for now because it brings a lot of other whole different topic that we want to talk about later on. So if we have a nat, which is this, let's simplify it to this, which is the same thing as writing nat. Okay, if you write nat, what we're writing is actually having a function that goes from nat to nat. We're applying sorry, I don't know how to write it properly. We're basically applying unit to this function. So we are getting back our nat. What's happening in the actual function is that this trunk function actually runs an effect, which is gen, and it's providing us with a random natural number. So here go runs, sorry, also let's look at it. So runs expect a nat, and then it expects another effectful computation or delayed computation. I think that's the term they use, delayed computation. So we have two ways to pass this delayed computation to runs. Either we write go with a use parameter, or, which is the same thing, we can do this and pass go as this. And I think it's just a matter of personal preference. Oh, sorry. What's happening? Oh, I think the indentation needs to be fixed, otherwise you won't be able to understand what's going on. And then we can do this. And it's not working. We can do this. Yeah, we're actually not allowed to do this. I'm sorry. I think we are allowed to do this. Let's see. Yeah, this works. So this is another way to do that, but I'm sorry, we're not allowed to do that because these have to be effectful, and if we don't delay it, these computations are not delayed, are invoked immediately, and then these runs actually can be run with a with something that's not delayed. So this delayed computation thing and ability is something that still have to completely wrap my head around. Sometimes I get confused a little, as you can see. Anyways, let's move to a very interesting topic, which is abilities. So let's look at uh, their definition, which is probably much better than what I can come up right now. So they give us two examples for functions. One performs I/O, and so it is an interesting type. We'll be explaining much more in this tutorial. So we have a message name which just appends a variable to a string, and then we have this function which runs print line and prints something to the console. So I found and type checked these definitions are okay to add, and as you can see, it's a function from text to unit by running some I/O. So I found it's much easier to get in the mood of how Unison handles this stuff by actually thinking that this I/O is linked to the function, to the arrow, and not actually to the unit. That's not how maybe someone that's used to to Haskell probably like to think of, but it's more like this. So this is a function that produces I/O that that uses the I/O ability. So notice that I/O attached to the arrow. We read this type signature as saying that greet is a function from text to unit, which does some I/O in the process. I/O is what we call an ability in Unison, and we say that greet requires the I/O ability. So yeah, let's try writing some code. So we can delete this stuff, we don't need it anymore. So let's write our greet function. Sorry, that's Haskell. Uh, so we get an error. The expression read needs the IO ability, but this location does not access to any ability. Why is this happening? Let's check here, because this is exactly what happens in their example. So the empty uh, curly brackets attached to the arrow of the grid type signature tells us the type checker we are expecting grid to be pure. The type checker therefore complains that we need the IO ability. Of course, we can write IO here, so we have two options. We can write explicitly IO here, and now this works. Can we do this? I don't know how to grid because we didn't add grid to our code base yet, so we can actually call it. Another thing we can do here is omitting this, and I think Unison should infer automatically that this is IO. Yeah, yeah, this works. Let me try something because I can't remember this working, but I'm not very sure. Yeah, okay, so there's a way to have kind of a main function in our Scratch file, so we can do this, and it's supposed to be this actually. Sorry. Let's see if this works. Main, and then we can do this, or we can do this, whatever. It's easier. And then we can do run main, and it works. So we can use the run command to run a function that has exactly this type. So it's a little like Haskell, where you have to have a main which is an IO, and here we need to this delayed IO computation. So there's our main, which is delayed. It just calls this greet. So let's go on with the documentation. Ability polymorphism. Often higher order functions like listmap don't care whether their input functions require abilities or not. We see such function ability polymorphic or ability parametric. For instance, here's the definition and signature for listmap. So let's go back to base. Let's view list.map. And as you can see, there's a polymorphic ability in here. So I think this function, when was written without the curly braces at all. And this is something that the Unison does by itself. So it infers that this one could have an ability and just puts it here. Notice that the function argument f has type from a to this e b. This means that this variable can represent any set of abilities according to whatever is passed in for f, and that the requirements of listmap are just the same as what f requires. And with f means this function. We say that listmap is ability polymorphic since we can call it with a pure function or one requiring abilities. So let's try. So we get another greeter function, takes a final message, and then we have x1, which is list map from x to x dot 1. This is how you write lambda in Unison of 1, 2, 3. Then we have x2, which is list map print line Alice, Bob, and Carol. And then it says print line final message. So if we save this, I get an error because we're not greet anymore. And these definitions are okay to add. Okay. Yeah, it's not super interesting, but maybe we can do something like this, some main, and then we can call this stuff. Does this work? Let's see. Uh, doesn't like this because I think this is supposed to return a value. Oh, I'm sorry. So this works. Let's try this. Let's try running main or main. Yeah, it works. Alice, Bob, Carol, hello. So yeah, our map function is polymorphic. It's running an effect. We don't need to have like specific versions for the pure and the polymorphic and the effectful version. So, creating and handling abilities. This is a pretty big topic. And it's also something that can get a little tricky because error messages and inference are it's not super perfect yet. So, so here this guide tries adding a stream, which is already in here. And we can probably just give it a different name. So let's call it producer. And instead of emit, let's. I kind of want to use yield, but I can't use yield either because it's from another ability. So let's call it give. Yeah, I like it. So give goes from E. Yeah, already got it mixed up to producer E unit. So this is how you define an ability in Unison. We can save and say that this ability is okay to add. And also look at this very cool thing. Unison is so smart that it's telling us, hey, you're trying to create this new ability producer, but we already have that. It's called stream. And it's exactly the same thing because it has exactly the same signature. We're just gonna ignore them because we want to create our own producer. So, what can we do? We can create a way to build a stream. So, following this example, the guide writes a stream.range. Which shows how we can use our give function to produce producers. We can think of the codes to give as suspending the computation, requesting that the give operations be handled by an external piece of code that will be interpreted by the give, and if it wants, resume the computation. So let's try writing it because it's very confusing now. By the way, this is completely optional, meaning that we can also write give from E to unit, and Unison will know that and fear that this ability is here. So basically the same thing. So we can write our producer.range, which takes nat, takes another nat, and it returns a producer of nats unit. So what we can do is if n, so just it's under recursion, if n is bigger or equal than m, we just return unit because that's the end result. Otherwise, we can give n and then call us back again, moving one step. Okay, now we are our producer range. So what happens if we call producer.range 0, 5? Yeah, I don't know how to produce a range. There's no really way because this is still a delay computation with an ability, and we need to handle it somehow. This means that we can define our abilities and our effects without caring how this will be handled. And this can be handled in different ways. For example, they could be handled in a pure way or in a factual way, contacting a DB, or in a like writing to reading from a file. Different ways to handle the same ability. So, for example, here in the guide, they define a producer to list, which is takes a delayed producer, returns a list of A. So how does this work? So let's see. Uses some specific syntax here, which is handle, which is a function that takes a delayed computation. It's actually, let's see, sorry. Did they explain handle? It's in the language reference. Let's go check if we get any definition. Handle. Well, I don't want to waste too many times because I'm already running a little long. So anyways, what this does, it says that it's supposed to handle our computation with a specific handler. In this case, we're passing to this handler an accumulator, which starts as an empty list. And then we can say here that this handler takes a list, so our accumulator takes a request for a producer. I should have changed the names. I feel like this made things much more weirder. Takes a producer A and returns a list. So this request, it's what's passed to the handler by using this handle. And now we can implement our handler, which takes an accumulator and returns basically a pattern match on all the possible abilities that our producer have. This is obviously producer range. I'm sorry. So, what can we do here? Our ability only has one method, which is give. So we can match on it. And the syntax is producer.give, which give us an E. And then what happens, this is the rest of the computation. This resume. The name is not specific. It could be any name. It doesn't matter at all. And it's just the continuation of our computation. So we're matching on this, and when we get our producer is giving us a value, what we want to do is handle the rest of the computation with our handler. So we're recursively calling our handler, but we are building up our accumulator with our new value. So now we can save. It says that everything is fine. So we could try, let's see if it works. Producer to list. A producer range from 0 to 10. Does it work? Doesn't work. Let's add our stuff. Does it work now? I don't know how to producer to list. Why is it not working? Okay, so here it works. We get an undo request because I guess we are not handling the end case. Yeah. So what we are doing here, we are matching on the ability method, which is only given in this case. But we also want to do something once our ability is not doing anything anymore. In our case, we want to return our accumulator. So let's check here on the guide. So the case from curly braces hue to ACK matches when there are no further operations to process, the pure case. You can be any pattern. It could be also the underscore. Since we are ignoring it. I guess there are some cases where we don't want to ignore it. I wonder why, when. Maybe we'll find it going on. We'll see. So now this works. When I save, I get a nice list from our producer. But I wonder why it doesn't work from here. I'm just gonna to randomly try a couple things. This doesn't work. This doesn't work. I'm a little sad that I'm failing and doing this. Uh, could probably be because it's an effectful computation and we can't just run it here as it is. So we'd have to do something like our main. So our main producer to list user range 0 10 run main. Looked for a function main. Main is this. Okay, it complains because this producer to list is returning a list of nuts, but main has to return a unit. So what we can do maybe is list map print line. It complains because a second argument to the function list map is base nat, but it was expecting base text. So do we have the dot here? Let's try. We need to find a way to go from nuts to text. And there's the toText function. So let's call it. I found the value of type base unit when I was expecting one of type base unit. Yeah, of course, because now we're returning an array. So let's do this. This is not going to do what I was thinking for it to do, I think. It does. So it runs the effect, but also returns an array. So what if I do this? Yeah, it's pretty useless because it's an array of units. It's not accumulating any value. It's a pretty weird function. Maybe we can do something. Let's try. Let's try writing this. I want this to take a function from A to B. I want it to take do you want to do this? Let's do a function from A to unit with some kind of effect. And it returns just an effectful computation. So F A's do you want this to be delayed or not? Huh. I guess so. We want this to be like this. So it takes also another discarded arguments. And then we can do list map FAs and then return a unit. No lexeme. I think this is because we are not allowed to use the apex here without putting a space in between. Let's comment this for now. Okay. I find this a little fortunate because I like to put the ability to the effect right next to the arrow because it makes it clearer, but it's not possible to do so with the apex. Which I have to retract what I just said because this actually makes sense because this is actually supposed to be this. So it makes sense for it to force us to put a space in between. I'm sorry. This video is a bit of a mess. So now we are map function and we can try using it. Let's see if it works or if we made another mistake. Um, it's complaining because this is a delayed computation. It works like this, but maybe then we didn't want it to be a delayed computation. So let's try. As you can see, it's still a lot of a trial and error process for me. Yeah, it's much better. Remove the delay computation from here, and then we don't need to force the computation here with the exclamation mark. And this works. We can just map, which is similar to what the effectful map is in Haskell. So now I'm just gonna embarrass myself. What we can do, we can add the stuff. So we did something that's a little weird because now we have a list namespace inside of our Dario namespace, and then we have a list namespace in base. So maybe we would probably want to do something like move term list.map to base list map. So now we don't have what's inside the list now. Nothing. The namespace are identical. Okay, cool. And now let's find map, which is inside base list map, which is makes much more sense. So, for example, if you were writing some code to expand the base namespace, the base library, sorry, we could fork base, add functions to it like we did here for this map, and then we could create a pull request all from inside of UCM, which is pretty handy. I'm not going to do that, but there was an example. If you go into the base library repo It's all explained in there. So now they give us an exercise. So writing our first handler. Let's try. So it's producer dot full left, which goes from B to A to B to B to delayed producer A, which takes a delayed producer A and returns a B. Okay, so let's see how it goes. We have our first argument, which is the f, our function. Then we have an accumulator, and then we have our producer. So, taking inspiration from the two-list handler above there, we can say that we want to handle our producer with our handler, which takes the accumulator. Let's pass to the full left. And now we want to do this handler, which takes an accumulator, which is B in this case, and takes a request for a producer of A's, which returns unit, and returns our B. So HACC is equal cases, producer give, so our producer is giving us A's, so let's use A as a term, resume, okay, and here we want to handle or resume with H. We want to pass to H our new B value, and we can build our new B value using F, using 8, ACC, our accumulator, and using A. And if everything is done, we just return our accumulator. Should work. Let's try saving. We don't get any error, which is good. We can delete this stuff up here, which we don't need anymore. Oops, sorry. Sorry again, what's happening? Oh, caps lock. Okay. So maybe what I want to do is let's try writing a function which does a list map print line to text of producer to list of a producer full left. I pass addition as a function, pass 0 as the first value. Oh, this is getting a little messy. producer range 0. It will never work first try. Yeah, this has to be delayed, and this has to be delayed to match the signature. The first argument of the function producer to list is base net. But I was expecting base unit. Let's do this. Producer. I think this doesn't have to be delayed. The first argument to producer to list is base net as expecting unit to producer A. Oh, this sucks. So we can say that this our list is producer to list. So let's find producer. Let's view footer. Okay, takes a delayed producer. And our full left. Okay, let's do one thing at a time. I feel like I'm messing this up because full left actually returns a value, so we don't need to do this. My bad. And we actually don't need to map it because it's a single value. So yeah, I don't know what I was doing. We can just print line. Of course, this has to be change text. This works. Remain. It works. Yay! Not as smooth as I was hoping, but yeah. So then we have challenging exercises. Let's try them. So we can add our full left. Producer.map, which takes a function from A to B, takes a producer of A's, which can return anything, which I suppose it can only be a unit because our producer only returns units, and returns a producer of B's. So let's write this. Producer.map takes a function f, and it takes a producer. So as usual, we want to handle our producer with our handler. I feel like we don't have any accumulator right now. We don't need them. So our handler takes nothing. So it just pattern matches on the cases. So let's write the signature. It's going to help us. Takes a request, producer A, R, returns a producer of B's. So we are our only case, which is producer.give, which gives us an A continuation. What we can do here is give f of A, so we're giving a B, so we're actually producing a B, and then we can handle the continuation with H. And then of course we have to handle this case. Or we just return R, the end result. Which we could fix to unit, because producer it's only has units as return value, but let's keep it polymorphic. It's not working because this has to be delayed. Still not working. I found the value of type request M. We're expected to find one of type R. Do we need to delay this one too? See, this is where Phil right now gets a little tricky because it's not super useful at times. What their messages tells you, and there's no way to use type tools or stuff like that, so it can get a little tricky. So let's try reading this more carefully. I found the value of type base request M. We're expected to find one of type R. Am I messing something up with the syntax? Let's find full left. Let's view full left. Oh, okay, yeah. My bad. I mean, I feel like this is something that could get much better error message in the future. So now maybe we can do this. Aha, interesting. Let's put everything as it was before, because I was trying to fix it. So I found the value of type B. We're expected to find one of type E. Why is it expecting a type E? There's no E anywhere. Give FA. Yeah, I just wanted to be sure. So F is from A to B, takes producer of A's and returns the producer of B's. Looks correct. Then we handle our producer with H. So we handle a producer of A's and we return a producer of B's. So let's try doing this first and this. Okay, so these type checks now. So we're actually returning a producer of B's that returns R, which actually doesn't produce anything because we're skipping the produce part. So now we have to figure out why this is not working. So I'm very curious why it assumes that this f of a produces an e. Where does it get this idea? What if I do this? Huh. It's pretty weird. So I'm not sure why this is happening. Let's look again at the full left. It looks pretty straightforward. I don't know why it's not working. Wait a second, sorry. So let me cheat a little. I have an older implementation that I wrote when I was actually checking this stuff on my own, and which is supposed to be working. So let's see, maybe that something broke. Okay. See, this is where it gets very confusing. The results is a delayed computation. So we actually have to do this. Uh, which are getting closer, but still it's not perfect. Let's see if there is something else that's broken. Typing this will help us. Fs equals handle s with h. So far it's identical. Uh, what? Just gonna type it quickly and see what happens. So let's just put this below the fold for now. Yeah, it's not working either. It's confusing. So I'm pretty sure this was working. Uh, I found a value of type B, where I expected to find one of type E. Why is it expecting with type type E? Where does it take it from? This makes no sense at all. So I guess this is where I would go for typos if I were writing Haskell, but suddenly we can do that. Okay. Feel like we're getting closer. Are we actually getting closer? Why does it include F? Ah, there is no one in chat that can help me, sadly. I have to solve this on my own, and I'm a little very short on time. I don't want to end the stream without doing this. I'm sure it's something like very trivial, and something that I've been hit by a lot of times. This is not working. I mean, there are solutions in the documentation page, but the solutions are written using another handler, which is pipe, makes things much more complex. pretty sure this is correct. Why is it not working? Why is it not working? It's producer map takes a function, a producer of A's, a producer of B's, returns a producer of B's, producer. So this is obviously just something trying to make it work. So let's do this. Let's say that it returns, doesn't do any transformation, it just returns the same producer. I found the value of type base unit producer AR when I expected one of type R. I feel like I'm going crazy right now. So these type checks. Let's see what it thinks this is. Uh, so I suppose if we do something like this, producer map x plus 1, this should type check or just return the same okay, return nothing because this is not actually producing nothing, but it works at type checks. So why do we do this now? Looks like it's working. And we can run it and returns the value. So why this is not working? This makes literally no sense. It makes no sense at all. These are just desperation moves. The first argument, the function h, is from I'm gonna get very angry if the cause is this. Oh well, I'm gonna stop for now for today. It's getting very late. I will try tackling this map and the other exercises next time. Thank you for listening. It was a very sad stream.